Alright, let's see how we go with this one. So we're expressing y equals sine x plus cos x in, first of all, the form r sine x plus alpha. So if we take r sine x plus alpha, oops, let's just go for that one, r sine x plus alpha, and we expand that. Sorry about that, we get r sine x cos alpha minus r sine alpha cos x. And that should be a plus. There we go. So hopefully that is correct. Now, if we compare that to our sine x plus cos x, right, because we want it to equal sine x plus cos x. All right, if I make that times 1, you can see that the r cos alpha must be equal to 1, and the r sine alpha must also be equal to 1. So if we do this equation 1 divided by equation 2, we would get tan alpha equals 1 on 1, which is 1. So we get this alpha being pi on 4 if our if that's yep, that's our acute angle there. And for r, if we take equation 1 and square it and add it to equation 2 squared, 1 squared plus 1 squared on the right hand side is 2, so we're going to get r squared equals 2, so r would be equal to root 2. So you can see that sine x plus cos x is the same as root 2 sine of x plus pi on 4. So we've got a phase of pi on 4, or the sine curve is shifted to the left pi on 4. So if we wanted to, let's go back to here for a second. If we were looking at, for example, just the sine curve, if I just started the sine curve, let's say from here, and I went, that was bad, but anyway, up, down, so I'm not looking at the grid at all. We know that usually for a sine curve, this would be 2 pi, this would be pi, and this, if this was 0 here. We'd also know the amplitude. In this case, we've got an amplitude of root 2, so that would be root 2 across there, and it would go down to minus root 2. All right, so if it shifts by pi on 4 to the left, everything's moving by pi on 4 to the left. So for example, this point, which was pi on 2, this is 1.5. There we go, 3 pi on 2. That looks bad, but anyway. So everything is, and I'll do it in, let's try green. So we're shifting to the left pi on 4. So this point here, where it was 0, is going to become minus pi on 4. Pi on 2, if I shift it by pi on 4, it's going to become pi on 4. If I subtract pi on 4, it's going to become pi on 4. This pi, if I subtract pi on 4, is going to be 3/4 of a pi, because it was 4 pi on 4, take over 1 pi on 4. So you get the gist. So you can just subtract each time. So for example, this is 8 pi on 4, so that becomes 7 pi on 4. This point was 3 pi on 2, so it becomes 5 pi on 4. So our y-intercept is going to be right here now. So it's moved over a little bit. It's not at the stationary point, it's before that. So you could, if you want, put, we could actually find the y-intercept fairly easily. We're just putting, of course, x equals 0 in here. When we put x equals 0 in, we get sine pi on 4, which is 1 on root 2, and we're timesing by this root 2 out the front, so 1 on root 2 times root 2 would just be 1. So we can do that to find the graph, and you'll get the same graph no matter what we do. So for example, if I then go and have a look at Well, let's just go like this. Yeah, let's. Alright, being lazy, try not to rub out what I might need. Let's look at this second one, r cos x plus alpha. So if I expanded that, I would get r cos x cos alpha minus r sin x sin alpha. There we go. And again, I'm comparing, although I could have, actually I'll write this the other way and put, instead of sin x plus cos x, I'm going to put 1 times cos x minus 1 times sin x, which is the same as sin x plus cos x, right? Alright, and I'm just lining that up so I can see nicely that the r cos alpha there is going to be 1, and the r sin alpha here is going to be r minus 1. There we go. Alright, so in this case we still, if I square the first equation plus square the second equation, I will still get r squared equaling 2, so we still get r equals root 2. So we've still got root 2, but this time it's cos of x plus. Alright, and we want our alpha. So if we think about our quadrants, we've got a negative sign but a positive cos. So we're looking in this quadrant here, which would be, we're in pies, yep. I think we're in pies, yep. So 2 pi minus our acute angle. So if we think of just tan alpha, forget about the negatives now, equals 1, we know that alpha would be pi on 4. So if I had a common denominator, this would be 8 pi on 4. So I'm going to get 7 pi on 4 here. So my alpha is 7 pi on 4. So again, we should get the same curve. This time it's a cos curve. It's still going between amplitude of root 2, so between root 2 and negative root 2. But we've got a cos curve, so you can think of it as starting here. That's the original, and then we're going to subtract 7 pi on 4 from everything. So in the end, you're going to end up with the exact same curve anyway, but you can play around with that and see how you go. I hope that helps.